Hello, welcome to this introduction to load balancers in the Savvisdirect CloudServers product. When you create your CloudServers environment, your servers will be provisioned with one internal and one external IP address. Now, let's say you host a workload on one of your servers that will be accessed by external users. A well-known example of such a workload is a public-facing website. To access the site, an end user would navigate to the individual server's public IP address, usually through a DNS-enabled address such as www.savvisdirect.com. The server then processes the request and delivers the web page back to the user. As the number of visitors to your site increases, you'll want to host a website on multiple servers and distribute the traffic across them. This is when you deploy our complementary load balancer. The load balancer is configured to work with multiple servers. When users want to access the site, they access the load balancer's DNS address. Then, the load balancer will send the request to one of the servers. The next request goes to the next server, and so on. The algorithm that defines which server gets which request is referred to as the load balancer rule. We have just seen an example of a simple round-robin load balancer rule. Another popular rule is the weighted round-robin. Here, the load balancer will still send requests to servers in turn, but an individual server may get a disproportionately larger or smaller number of requests. For example, we could set the weights to 2, 2, and 1. Then the first two requests will go to the first server, the next two will go to the second server, and the fifth one goes to the third server. Another rule we can use is called least connections. Here, the load balancer will monitor the client connections that each server has and send an incoming request to the server with the fewest number of connections. This is useful if you have similarly sized servers and workloads, such as a clustered database. Now, there are several benefits of deploying load balancers. First, using multiple load balancers provides a disaster recovery failover option. Let's say you have a load balanced website. If one of your servers goes offline, the other servers in the load balancer combination can assume the workload, thus minimizing downtime and lowering your total cost of ownership. Next, you create an enhanced user experience. Again, let's use the example of a load balanced website. Too much processing on one of these load balancers will result in fewer customer additions and more defections of current customers. In this case, you can simply add one or more servers to the mix to increase site performance.